Alright, we are on investigation 1. Our objective says I will be able to use experiments to find the probability of an event by calculating likelihood. So probability is just, that's our first definition, probability is the measure of how likely a given event or outcome will occur. So I think of probability in terms of something like if you're going to the casino at the Isle of Capri and you're trying to win some money. The probability that you are going to win money is not very high. You can calculate it by the number of times that you put money into the slot divided by the number of times that you actually win money. So probability is used in things like gambling, it's used in things like sports, to think about how many times a team wins against another team or how many times a certain person gets a hit based on this picture. People use probability, which is how likely it is that an event is going to occur. Now the probability can be written as a fraction or a decimal ranging from 0 to 1, or it can be written as a percent. So probabilities can be written as fractions, decimals, or percents. So to calculate probabilities, we first need to understand what that means in terms of how likely it is that something will happen. So our directions for this first thing says to describe, for our first example, says to describe the events as impossible, unlikely as not, likely, or certain. So these are our options: impossible, unlikely, as likely as not, which means there's like a 50-50 chance it could happen, it couldn't. Likely, it's probably going to happen, or certain, it's definitely going to happen. So Jake rolls a number less than 7 on a number cube. Think about a number cube. It's labeled 1, 2, 3, 4, 5, 6. All those numbers are less than 7, so this event is certain. All right, we also want to make sure we put an explanation. All the numbers on a number cube are less than 7. It's 1, 2, 3, 4, 5, 6. So this event is certain. It will definitely happen. If he rolls that number cube, he's definitely going to get a number less than 7. Next one says February will have 30 days. This event is, well, think about how many days are in February. There's either 28 or 29, depending on the year, so it's never going to have 30, so this event is impossible. My explanation is February has either 28 or 29 days. It has either 28 or 29. It never has 30, so that is impossible. On the leap year, it has 29. Regularly, it has 28. A tossed coin, number 3. A tossed coin will land on tails. This event is, well, I've got a heads on a coin. I've got a tail. I want to make sure everybody has that one. And that one. I've got a heads on a coin. I have a tails on a coin. So it's equally likely that I could land on heads or tails, so this event is as likely as not. Okay? My explanation is a coin has 1 heads and 1 tails. So it's equally as likely that I will land on heads as I will land on tails. Anytime I flip a coin, I have a 50-50 shot. I can either land on heads or I can land on tails. Shayla correctly guesses a number between 1 and 100. Think about all the numbers between 1 and 100. There are a lot of them. Okay? So if I am talking about correctly guessing just one of those numbers, that's not very likely to happen. This event is unlikely. And my explanation is there are many numbers between 1 and 100. Okay? Between 1 and 100, I've got all those numbers. It's unlikely that I'm going to guess, or excuse me, that Shayla is going to guess correctly. If she has one chance to guess that, it's unlikely with all the different choices that she's going to get that correct. Now, that is a way to measure probability in thinking about it conceptually. Is it likely that something's going to happen? That's all probability is, trying to decide how likely it is that something will happen. Now, you can calculate this and give a percentage to it. You can calculate this using the following formula and using the following term. Experimental probability is the measure of how likely a given event will occur based on repeated trials. So if I do something over and over, how likely is that event to happen? I can calculate that and give a number to it. So to find that, I just have a really easy formula. It is the number of times an event occurs, the number of times an event occurs divided by or over the number of trials. So the number of times an event occurs divided by the number of trials. So if I do something over and...
Not trails.
I spelled trails again. I keep spelling trails. Trials. See? My filmmaker's catching me here. The number of trials. Okay, so if I keep doing something over and over, how likely is it that that's going to occur? I can come up with a percentage or with a decimal amount that will tell me how likely that is, or the probability that that event will occur again. So here's an example. I think of experimental probability in terms of something like this, a batting average. If a player gets 8 hits in 25 at-bats, what is the probability that he will get a hit on his next at-bat? Express the answer as a decimal and as a percent. So to figure that out, I just use this formula. The number of times an event occurs divided by the number of trials. So in 8 out of his last 25 at-bats, this player has gotten a hit. So all we have to do is divide that out to turn that into a decimal. So to do this, I'm going to take the numerator and divide it into, the denominator and divide it into the numerator. I'm going to divide 25 into 8. How many times will 25 go into 8? Well, it won't go any. So I'll put a 0 there. I add a decimal here and bring that decimal straight up, and then I can add a 0 here. How many times will 25 go into 80? Well, it'll go 3. 3 times 25 gives me 75. I subtract. 10 minus 5 is 5. I can add another 0. Now, how many times will 25 go into 50? 2. 2 times 25 gives me 50. So, 8 out of 25. I've calculated this, the number of times he got a hit out of the total number of trials out of his 25 at-bats. I use this formula. Number of times an event occurs divided by the number of trials. That's 8 hits out of 25 at-bats. When I divided that out, I got 0 and 32 hundredths. It says to express the answer as a decimal and as a percent. So as a decimal, it's 0 and 32 hundredths. To turn that into a percent, I can either multiply by 100, or I can just move the decimal to the right 2 spaces. Okay? That gives me my percent, which is 32. So 32%. So there's a 32% chance that on his next at-bat, he's going to get a hit. I figured that out by determining the experimental probability. We can do the same thing with number 6. A piston manufacturer is concerned with the likelihood of defects, as this affects costs and profits. The manufacturer inspects 250 pistons and finds that 8 have defects. What is the probability that a piston will have a defect? Well, we say the number of times an event occurs, so the number of times an event has a defect, so 8, divided by the total number of trials, which is 250. All I've got to do is divide 8 divided by 250. Again, you can divide the denominator into the numerator. If I do that, I'll get this. I'm not going to divide that out right now. But I will get this as, oops, that's wrong. Forgot my 0. I will get this as a decimal, 0 and 32 thousandths. So what is that probability? It says to express that probability as a percent. So this is my answer as a decimal. I want to go ahead and express that as a percent. To do that, again, all I've got to do is move the decimal 2 places. That gives me 3 2/10%. So there's my answer as a percent. Now part B says if the same manufacturer produces 3,000 pistons, about how many will likely have defects? Well, what we figured out is that there is 3 2/10% chance, or that's 0 and 32 thousandths. Same thing. 0 and 32 thousandths. 0 and 32 thousandths, that is the experimental probability. 3 2/10 is that number as a percent. Sorry, I said that incorrectly. So if the same manufacturer produces 3,000 pistons, about how many will likely have defects? So to do that, all I've got to do is multiply this decimal amount, this experimental probability, by the number of trials this time. Okay, so I've got to take 0 and 32 thousandths and multiply it by the 3,000 that are being inspected here. Okay? If I do that, I get, you could go ahead and multiply this out. I'll multiply it out for you, because I don't want to have to spend our time just multiplying. But if you multiply this out, we should get 96. Okay, so all we did is we took the decimal amount, we took this experimental probability, and we multiplied it by the number of pistons that are being inspected. So 96 pistons. So if the same manufacturer produced 3,000 pistons, we could expect that 96 of them will likely have defects. Okay? So to show that that is the same thing, what I could do is say that 96 is how many will have defects out of 3,000. If I divided that out, I should get this same decimal. I should get 0 and 32 thousandths. Which again, if you took that and divided it out, you will see that it is the same decimal. Okay? So 0 and 32 thousandths or 3 and 2/10%. So there's a 3 and 2/10% chance that there will be a defect in the manufacturing. So if 3,000 of them are made, we would expect that 96 of them would have defects. We're going to skip C, and that will be all for this lesson.